All right, so we've seen the basics of inheritance. Now let's dive a bit deeper. So we have our animal class and our cat class that inherits from animal, but right now they don't really do anything. Well, cat has zero functionality, has nothing different than animal. So let's switch it up a bit. Here's what I'd like to do. So we have animal and we have a cat. Each animal has, a species and a name. So Tony the tiger or Jim the sloth. A cat also has a species, which is cat. It has a name, like Blue, and maybe it has a breed as well, and a favorite toy. Something like that. So let's start by setting up animal correctly. So I'm going to get rid of this class variable or class attribute for now. And let's just do init, self, and every animal has a species. Let's go with name first, and then species. And then we just set self.name equals name, self.species equals species. Okay? And otherwise, we'll leave animal alone. Now, when we define a cat, we need to add our init, of course, and it needs to start with self. And every cat is going to have a name and a species, a breed, and let's just call it toy. And I could just manually define them. Self.name equals name. Self.species equals species. Self.breed equals breed. Self.toy equals toy. And I could do that, and that works just fine. When I make a new cat, I just need to specify this is Blue the cat, and she is a cat. She's a, Scottish Fold. And her favorite toy is string. Okay? And I need to comment this invalid code out. And why don't we just define a nice def repr represent method. I honestly don't know how people pronounce that. And let's just return a simple string that just has like the name. So we'll do self.name is a self.species. And actually, we could just put this up in animal here because every animal has a name and a species. Okay, so if we do this right now and I just print Blue, we get Blue is a cat. Blue, the cat, is inheriting this method from animal and is able to call it. Well, print is calling it. We're not explicitly calling it. But anyway, let's now focus on this here. This is duplication. And this is kind of the whole point of inheritance, is to avoid this sort of scenario where, the idea is that an animal contains all the base functionality that every animal has, and a cat will only have the additional things like breed and toy. So what we can do is say when a new cat is created, we're actually going to use the init in animal first and set up a name and a species. And then afterwards, we'll set up breed and toy. And the first way we can do that, the uncommon way you probably won't see, is to manually call animal._init like this. And then we actually have to pass in self, referring to the cat instance. And then after that, we'll do name and species, which is this name and this species. So we can do this, and if we actually test this out, it should work just fine, hopefully. There we go. We still get Blue is a cat. And we can still print, let's do blue.species, and then let's also do blue.breed and blue.toy. So you can see some attributes are being defined up here in animal, and some are defined down here in cat. And all of them print out correctly. So this works totally fine to do class name dot init and then pass in self as the first argument. But Python has a little bit of a shorter way of doing it using something called super. So if you type super with parentheses, it's going to refer to the base class or the parent class of whatever the current class is. So it changes depending on context. So super inside of the class cat refers to animal. And then I can call dot init. And the nice thing about super is I actually don't have to specify self anymore. It will automatically be passed in. So I can change this to just be name, comma species, like this. And let's verify that it works. There we go. So I can replace animal.init self with super, which will return animal, and run animal.init and pass in self as the first argument. The other small change I could make here is species for a cat is always going to be a cat. So I might just do this. Species equals cat. Remove that from the init in a cat. We don't have to specify when we're making a new cat that it is a cat. And now we'll just have breed and toy, just like that. And just to show you, let's define a method on here called play. And it should just, let's have it print instead of return, which is kind of uncommon, but it makes it easier to demo. Let's just have it print self.name plays with self.toy. Okay, and then I should be able to call blue.play, which is an instance method on cat. And we get blue plays with string. And that pretty much wraps up this simple example. So just to recap, we have two classes, animal and cat. Cat inherits from animal because of this little line here. And we don't have to involve super, we don't have to involve the init method from the parent class if we don't want to. We still would have access to things like make sound or any other instance methods or class variables, class attributes, class methods defined on animal. But to reduce duplication, we didn't want to redefine self.name and self.species down here in the cat init. So instead, we can just call animal.init, and the shortcut is super.init. Super refers to animal, and it looks for the init method in animal. And that's pretty much it. So that's the basics of inheritance, at least the simplest form of inheritance. I'm going to show one more example in the next video with users and moderators, and we'll see how it works with class attributes. You can watch that if you want, another example, or move on and learn about multiple inheritance, which is where super really becomes super useful. It really does become more useful though. So see you in a bit.